Good morning, my dear subscribers, viewers of my videos, and my supporters. It has been a while. I've not talked to you about the issues of science. Now, for the ordinary level students, from this very day and in the days ahead, I'll be giving you audio lectures, though sometimes video lectures, depending on the need, on organic chemistry uniquely. I've organized organic chemistry into 14, ordinary level organic chemistry into 14 chapters. So I will advise you, if you have not subscribed, if you are watching this video in my channel for the first time, I will advise you to subscribe so that you benefit from this. Because I'm going to help you unravel the mystery of organic chemistry, especially those who are just starting organic chemistry. Organic Chemistry Audio Lectures by OBI.S.N, Dr. Science. Chapter 1, Introduction to Organic Chemistry. By the way, what is organic chemistry? I'll give you two definitions. The first one is, organic chemistry is a study of substances of plants and animals' origin. That is, substances formed only by living things. The second definition is, organic chemistry is a study of compounds containing carbon, with the exception of simple compounds such as the carbonates, carbon dioxide, carbon monoxide, and metallic carbides. This second definition makes us to understand that not all compounds containing carbon are studied under organic chemistry. We have seen that metallic carbides, carbonates, and oxides of carbon, namely carbon dioxide and carbon monoxide, are conventionally studied under inorganic chemistry. As you begin your journey of organic chemistry, you must know the constitutive elements of organic chemistry. These are: 1. The main element is carbon. 2. The usual elements are hydrogen and oxygen. And 3. The occasional elements, namely nitrogen, the halogens, phosphorus, sulfur, and some metals. But wait a minute, why are there many organic compounds? I'll give you 3 reasons. The first one is, carbon atoms have the exceptional ability to cartonate. What is cartonation? Cartonation is a formation of a chain structure by the bonding of atoms of the same element. For example, carbon in the hydrocarbons. Carbon atoms have the ability to combine with one another to form straight chains, branch chains, or ring compounds containing many carbon atoms. Again, the second reason why we have many organic compounds are, carbon combines with hydrogen, oxygen, nitrogen, and the halogen with ease. And thirdly, carbon has the ability to form single, double, or triple covalent bonds. Before I go to the next heading, I want you to understand that other elements in group 4 have the capability to cartonate, but carbon does that extensively. And equally, other elements in the periodic table that you know have the capability to combine with hydrogen, oxygen, nitrogen and halogen. But they do that with difficulty, whereas carbon does that with ease. Hang on, let's look at the characteristic features of organic compounds. The first one is covalent nature. I want you to understand that a carbon to carbon single bond has energy of about 346 kilojoules per mole. This is a nice way to tell us that it is a strong bond. The carbon to carbon bonds make organic compounds to be stable, non-ionizable in solution, and are non-conductors of electricity. 2. Polarity and solubility. Carbon to hydrogen bonds are non-polar like the carbon to carbon bonds. This is because of the almost equal electronegativities of the two elements. Most organic compounds are therefore non-polar unless the compounds consist of very electronegative elements like chlorine or groups like the hydroxyl group. The latter are soluble in water because they form hydrogen bonds with it. Non-polar substances are held together only by weak intermolecular forces such as van der Waals forces, and they will intermingle or dissolve only in non-polar solvents like benzene or ether. 3. Low melting and boiling points. In fact, this is because organic compounds generally possess weak intermolecular bonds or forces, which can be easily broken by heat energy. Those with relatively low molecular masses tend to be volatile and, of course, boil at temperatures below 300 degrees Celsius. 4. Thermal instability. Most organic compounds decompose to simpler molecules when heated to temperatures above 500 degrees Celsius. This property is of commercial importance as in the cracking of petroleum or crude oil. 5. Flammability. Most organic compounds are flammable and burn exothermically in a plentiful supply of air to yield carbon dioxide and water. The combustion of most fuels like wood, petrol, oil, coal, and natural gas provide our main source of energy. And lastly, 6. Reactivity. Reactions involving organic compounds tend to be much slower than the ionic reactions commonly encountered in inorganic chemistry. They usually require heating, thorough mixing, and catalysis to speed up the reactions. Thanks for listening. Thanks for your keen attention. In our next audio lectures, we'll be focusing on Chapter 2, Terms Used in Organic Chemistry. In order not to miss that, like this video, comment, subscribe to my channel to receive notification for the next video. Bye-bye for today.